Hello and welcome back to Polytoots. This video should come as no surprise if you watched my last one, which was making this flow map shader with Amplify. So with this one we're going to be using Unity shader graph, and I figured rather than just do a straight conversion of the Amplify one that I built, instead I found a different one built with Amplify, and I found this in the Discord channel. So whoever I got this off, I can't find you to credit you, so let me know who you are so I can just give you a little mention. But either way, we're going to be converting this into a Unity shader graph, so it should be pretty cool. And for those of you who are completely new to this and who have no idea what a flow map is and how you're able to do such a cool effect, it's essentially a texture that we use as UVs, which define the direction of the texture that you're using on your material. So in this case, it's moving our water based on this. And if I can open this up. Kind of hard to see, it's very faint normal map. This has been made using a free program called FlowMapPainter, and a link for that will be in the description. So all pretty cool. Let's just go ahead and start making this. Alrighty, so we're here in a new scene, and before we kick off I should just mention that these rocks have come from the Rocks and Boulders 2 pack, which is free on the asset store, and some pretty cool stuff. So it's mostly just rocks, as you can imagine, and boulders too. But yeah, pretty cool. Definitely worth a grab if you're playing about with any rocks. But for us, let's just go ahead and we'll create a shader, and this will be a PBR graph, and call it whatever you want, but I recommend using the word flow map in there somewhere. I'll do PT, 10 points if you can guess why. Just open this up. And okay, the way that we're going to go about this, let's just expand this up. But we're going to just create a bunch of stuff first, but then we're going to convert it into a, what does Unity shader graph call it? The subgraph, I think. So we're going to make some stuff and eventually at the end convert it into a subgraph, because you'll see why. It'll make a lot more sense there. As I say, we are converting over that node for Amplify that I found, and you may have noticed that it had a node called constant bias scale. Obviously, if you do a search and try to find that on shader graph, you're not going to find it. You'll have a constant, but that's not what you want. It's actually just quite a simple setup. It's a vector 1 with a value of -0.5, and then it is an add node, and we'll just add this into here, and eventually we'll have some other nodes that will hook into this. For now that'll be just fine, and then we'll get a multiply, if you can spell correctly, and we'll multiply the add by another vector 1, and we'll multiply by a value of 2. We could just put 2 in here. In fact, there's already 2 in there by default, but just to be absolutely sure, not to be sure, I mean, it would work fine, but just so we know that we are hooking in our own value, we'll do that. Otherwise, you can just leave it. It will automatically multiply by 2. And then this we can grab, and we'll just group this. And this is essentially the exact same. So this is a constant bias scale, which we're going to need because shader graph doesn't have that as a subgraph, I suppose. We could convert this into one now, but no point. Might as well just use it. We only have to use it twice, so that's fine. And so to kick things off, we will grab ourselves a texture sample, 2D, and this will be the flow map. Let me get that out, the blackboard, and we'll create a texture 2D, and we'll call this flow map. And so that will be obviously the flow map. And much like in our example, we're going to get a UV node here. Eventually we're going to change this up a bit, but for now we'll kind of just copy what was there, and then we'll look at why we should change it. So yeah, we'll keep this here for now. And much like with Amplify, where we do the component mask, the way that you do that in shader graph is by splitting and then combining. So we'll go split first, and then we'll put in a combine. And we only want the red and the green channels, because they're the only channels that actually have any information in them from our flow map. And now this is what goes into our constant bias scale. So we can hook that into there, and all is dandy. And then we'll come over here and we'll stick down another multiply, feed that through, and we'll just grab ourselves another vector 1, because we're going to multiply by a value of about -1. It was -1.1 in the example on Amplify, but I found there to be pretty much no difference, and -1 is just easier to remember. and then we'll multiply this again, but we'll leave the B slot blank for now. I'll explain later when we get there. And then we'll get an add node, and this is also going to be left blank for now. And then we will grab ourselves another texture sample 2D, and we'll come up here and make ourselves a new texture 2D. This one will be like the actual the texture that you're going to be manipulating. So, you know, call it whatever you want, but I recommend texture for now. That will make sense later on. So put that in there, and this is the UVs, which might seem a little bit strange, and we've also left, you know, the multiply and the add blank. And the reason that we've done this and why it's not quite the same as what it is on the Amplify version is, well, the multiply will be our time stuff, and I've chucked in an add here just for the extra tiling for the texture 2D that we have here. And I mean, this is probably not making too much sense because we're going about this in a bit of a weird way, but basically what we've done is we've just created some UVs for our texture, and the UVs will be a texture itself. It'll be this flow map. But of course, as you might suspect, if we were to just go ahead and stick this into the albedo now, and then let's save this out and give it a quick look. So I'll just come here and create a material, put that on our plane, and let's just make this a little bit smaller here. And so now it wants a flow map and it wants a texture. So we do have a couple of example flow maps. Let's stick with this one for now, the outward one, and we'll hide our rocks for the time being. And then obviously it wants a texture. So let's try to find something that hopefully looks a bit, you know, easy to tell what's going on. Okay, this one will do, plastic ridges. So yeah, you can see that it's not it's not right at all. But we are definitely affecting the UVs in some shape, way, or form based on the flow map. So if we were to put in a different one here, which is this S-curve, you can see that it is taking that shape. It's just obviously completely wrong. Let's just go back to the outward one for now, and let's come back in here. So we know that we're doing something correct because we are affecting the UVs of our texture, but obviously there's no movement. And so for now, what we'll actually do is we'll work on the time, so then we can at least see something move, and it will be easier to identify, you know, like what's actually happening. And so the way that we will do that is we'll start with the vector 1, which we will convert to a property, and this will be our speed. And is it just me, or does everything take forever in shader graph these days? Just trying to rename something takes like a good 12 seconds. Anyway, we're going to multiply our speed by time. I'll also probably give the speed a default value of 0.5 or something, just so it's actually moving from the first time that we launch it. And so here we can get a fraction node, and we'll hook this time into it, and we'll just for now plug that straight into the multiply. I say for now, that is pretty much the whole thing, at least for the first one. So that's, if you remember from the Amplify one, or if you've seen the Amplify one, or even if you haven't seen the Amplify one, basically we are going to move our texture using these UVs over an amount of time, and then we have to do that again with the same texture but slightly offset, so that there's essentially one that's always kind of going over the other, which we need to create, you know, a mask so that the transition between the two is not so obvious. But either way, if we were to just hit save on this now that we've actually hooked in some time, we should start to see something. Yeah, pretty cool, eh? Obviously, still not correct, so let's just keep chipping away at this. So since we now have some time, we might as well alter it a bit and create our second set of UVs, which, as I said, is basically just an offset of 0.5. So what we can do is we get an add node, and we'll hook the time into that, and then we'll just get a vector 1 and give it a value of 0.5. Again, I mean, if you wanted to, you could just put that in here, but I don't know, I guess I always just tend to work with actual properties anyway. So that's our offset, and we're also going to need a fraction again. So it's basically the same as this, but we have our offset. And now this is going into multiply, but if you remember, so from here for the first one, we go from fraction, and then straight over here into this multiply, which is feeding off of our constant bias scale and the multiplication of -1, which ends up being our UVs. And so it's essentially the same thing. So because since this is going into this multiply basically is the clone of this one. So what we actually want to do is grab the multiply that comes after the constant bias scale and just hook this in down there, and then that can go, the fraction can go into that new multiply, and then we'll go ahead and do another add. I definitely did that right. Add. There we go. Come on. And this will be the exact same as this. So we'll just copy paste these, and there's our UVs for that. And so now we need to loop these two together, and we can have another preview to see what's happening, because you saw what was happening when we had the first one just hooked in. So now we're going to see the same thing, but we have an additional one now with an offset, and also the lerp, which again, for now I'm just going to test. I did the same with the Amplify thing. So vector 1, we'll convert this into a property. Again, this is just to test. We'll turn it into a slider, default 0, min-max of 1. No need to give it a name because we are going to get rid of it. And let's give that a save. Pretty much going to look exactly the same. So there we have the first one and then the second one, but you can see as I scrub through, it's a little hard to tell, but it's obviously not playing this, animation is the wrong word, but it's not messing with the UVs at the same rate. You can see as I fade from one to the other, we see the other one at a different point in time. So that's good. It's very good. Let's just get rid of that temporary vector 1 for now. And also delete it from here because we don't need it. Yeah, okay. While we're here, we might as well actually use these add nodes that I put in here. The reason that I had them blank is we will use a tiling and offset. This was the main thing that was kind of different from the Amplify one. The Amplify example had one UV controlling all of it, so it was this one, which we don't actually need, so that was a bit pointless. Yeah, so it had that controlling the whole thing, so you could alter the tiling, but you couldn't alter the tiling separately, so that was why I decided to change this. And we'll create, well, I'll do it this way, create a vector 1, and we'll call it tiling, and I'll give it default value of 1, and stick that into the tiling. And then we just copy paste this. Oh, come on, and you. And then that is going to go into this second add. And essentially what all of this means is that now we can actually control the tiling of our diffuse texture, but the tiling of the flow map stays the same. And so we can actually just copy paste this. You don't, as I was mentioning in the Amplify tutorial, you don't really need to tile your flow maps, but I guess, you know, it's good to have the ability should you want to. And so for this, we just create a new vector 1 because this will be your flow map tiling. And again, I'll give it a default value of 1. Okay, so that didn't really change much. We just now have the ability to tile our textures separately. So what we will do now is make a little bit more space. We need to essentially plug something into this lerp. The T slot, or alpha, the mask basically, will be the point at which the textures overlap. We need to make them kind of merge to basically hide that transition where it snaps back and becomes, you know, really obvious that it's just resetting the UVs. So we'll come over here again, and this is going to be pretty simple. We'll just copy our group, and we could grab this fraction and stick it straight into the add here, but it's kind of messy how everything goes over each other. It's one of the nice things that I like about Amplify, that you can use the get type of thing where you can basically turn a node into like a mobile node, so it you know, you don't have these wires going all over the place. So anyway, we'll create another fraction, or you can use this one, as I said, if you want. and that one will go into the constant bias scale, and then it's just an absolute node. And that is basically it. So we'll hook that into there, and we will give this a test. Looking pretty good. We can control the speed. We can't yet control the strength, so we still need to add that in. And we have the tiling, which will just tile our texture. And then we have the flow map tiling, which you may or may not want, which it can come in handy. So let's go back into our graph here. We need to add in the strength as well, something that defines like how much of the texture gets distorted. And where we will put those is basically after the multiplies that we have here. So let's make ourselves a little bit of space. And we'll just create another multiply. I'll copy paste that just to make it a little bit easier. So before it goes into the add, we will multiply, and then same with this guy, multiply to multiply. And then we'll get a vector 1 and convert to a property, because this will be our speed. Nope, it'll be our strength. So that goes into there, and we might as well just use the same one straight into there. And we'll give this a default value of, again, like 0.5. And so that goes into the add now of both of them. And then we'll see what that looks like. Okay, so if I set this to 0, bada bing, bada boom, we get nothing. Set it to 1, we get that, and obviously we can control just how much. So yeah, you kind of don't want to go too crazy. Oh, and also you can invert it here, which is kind of handy. So yeah, pretty cool. Let's leave that at a value of 1 for now. And now comes the point where we pretty much have no choice but to convert this into a subgraph, because this is only going into the albedo at the moment, whereas ideally you also want it to go into your normals and your emission. We need to convert this into a subgraph, and we don't need let's just convert the whole thing for now. So we'll just select everything, right click, convert to subgraph. And I guess if you're the type of person that makes your own subgraphs, it kind of makes sense to have your own unique folder for that somewhere. For me, I'm just going to stick it in with the actual tutorial, which is oftentimes not the best place to put it, but just for me, it's fine. Okay, so once it's done, obviously what it leaves you with can be quite confusing and scary, so we don't need these anymore, don't need that. This is the actual subgraph that it's made, so now if we were to search for the flow map, we would have a USG flow map, which we can use, but we need to do a little bit of tinkering here, because obviously we don't want all of these inputs, because there's just too many. So let's go ahead and find our subgraph, and let's expand this. So everything kind of should look a bit familiar, but oh wow, it puts everything over there. So we have our texture, and the texture, which we're going to get rid of because it will be using the same one. Let's just tidy this up a little bit. So we need to get rid of this property here because it's created 2 of them. And then same for the tiling, it's created 2 of them. So let's just go ahead and move that there and that there, and we'll get rid of either one of them, doesn't matter, we only need 1. And then that tiling can go into there, get rid of this vector 1. And I think that's it. I'll quickly just have a look around here. So we only have 1 of these, we only have 1 speed and 1 strength. So yep, I believe that is fine and dandy. So let's just save this, close this now. Actually, I'll keep it open just to show you the next thing. So let's go back to our shader graph, and everything's updated itself here, which is nice. So this is obviously very easy because if we wanted to, for example, now we just grab our things, we say this was the texture, this is the flow map, and then I'll just hook in the rest as well. Man, that took forever. Okay, so yeah, we have all of this, and so that's going into the albedo, which is fine. And if you wanted to do the same for your emission, then you'd basically just copy paste the whole thing and then put that into emission. The only difference being that you would have to create a new texture, like a new texture sample. So like this, you know, and then you call it emission and then just make sure that that overwrote the texture that was there. And that would be that, just so it was a different texture. I'm not going to be doing emission for this, although, you know, it is as easy as that. What I will be doing though is a normal map. And the problem here is, of course, if we go back to the subgraph, typically like here on the sample texture 2D, this is where you define the type of texture that it is, whether or not it's a normal map, which is a bit of a problem because there's no point in us creating two subgraphs where we just have one where it's on default and then another where the sample textures here are on normal map, and then, you know, you'd search for, let's say, your flow map. We can't see it because we're in the so let me go back here. You'd search for your flow map and you'd see, you know, USG flow map and then another one like flow map normal, and that's super lame. Obviously you wouldn't want that. So what you can just do, let me just copy paste this. Let me just first actually, let's create the texture 2D. Oh wait, do we have this one we're not using? Oh, because that was, okay, well, yeah, we'll use this. We'll just call this one normals. And we'll plonk this down here. And now obviously if I were to just try to put this into my normal slot and hit save and take a look at it, and then come down here and basically just find, you know, some normal map. We'll try to use the same one, plastic something. That'll do. You see, it's not right, you know. It's not how it should be looking. You've got this weird normal issue basically, because this is not treated as a normal map. It's basically the same as us plugging a normal texture into the normal map slot, which it doesn't want. It does not like that. So instead, what I found that works is if you just search for normal, and it's either, I forget now, it's either the normal from texture or the normal unpack. We'll try normal unpack. That sounds like something I would have tried first, so we'll see what that does. Let's just save this. And let's take a look. Yeah, that looks pretty correct. And the one way to kind of test for this stuff I found is quite good. If you just duplicate the plane, and let's just give this a strength of 0 for now. And then what we'll do quickly, we'll just create a default material, and we'll put this on our new object, and then we'll just make sure it has the same textures as the one that we're using on our shader. And it might look a bit weird because this one actually has baked information on it from the level that I was doing, but you can see that the normals are behaving the exact same way. And if I just come up here and just clear my baked data, oh, it's still a bit dark. Okay, yeah, sorry. So the by default these are gray, so if I pump that up to white, so that's an exact representation basically, and it's the same. There is a little bit of strangeness there. That's probably just a light in my scene. Yeah. So yeah, I know that that's the same. So happy days. That definitely was the right node. Took us a while to get there. So let's put this back up to strength 1. And I mean, that's pretty much it basically. You don't need to do too much. What I will just do here is grab ourselves a multiply, and we'll multiply this by a color, which we're going to just use to tint basically our diffuse. So we'll convert that to a property, and I'll just call it tint. And the reason that we don't put this in the actual subgraph is because, again, we're using this to also do normal map and emission. So you might not want, you know, like 3 types of color that you can change, especially not on your normal map. On your emission, yes, probably, but maybe not the same as what you have on the albedo or diffuse. So default black is fine, I guess, and we'll put that into the albedo instead. And let's just reorder these a bit so it makes a bit more sense. And let's come back. And yeah, so because our color tint was black, instead of white, it comes out like that by default. But now at least we can change the color. But I guess probably one thing I will just do quickly is change, or just close the window, I guess. I mean, to be fair, we're probably done with the thing anyway, but let me just go and get that back. Okay, yeah, so the color, I'm going to actually just change default to be white. That does make more sense. And that's about it. So now I'm just going to reconstruct that scene that I had. So I have my flow map, the water. Obviously it looks pretty weird here. The texture, I'll show you that in a second. Let me just go do none for now. And the normals, I just have some generic watery type thing. Pretty good. We can again, change the tiling of this so it's all good. And let's unhide my rocks. That's fine. So obviously now, it looks like some sort of milky thing. And what I was doing actually, just for the diffuse, is I was using something kind of similar to the rocks themselves. It's a neat little trick. If you have something like this, obviously that's kind of muddy. I just realized that we forgot to do smoothness, obviously. So let's just go and crank those in real quick. Just going to get 2 vector 1s, smoothness and metallic, and just hook those in. And make them both sliders. Okay, so now we can actually give it like the proper shininess that we need. Something like that, yeah. Probably want to increase that speed a bit. It's a bit lame. But it's essentially just for like a quick kind of cheap watery effect from this specific kind of angle. You can just use some sort of texture that's close to the environment that you are using, and it's I think a pretty okay way of getting some sort of illusion. Obviously you can tint the color of the water just like a bit. Obviously I wouldn't go too crazy with it if you're aiming for anything close to realism. And since I cleared my bake data, my scene is so much darker now. Let me just go and get that back. Okay, that's way better. Yeah, so as I was saying about the little kind of trick where you just basically grab a texture that's, it's definitely not a water texture. Like this one, yeah, this is just like one of the rock textures. Just one of these. I do recommend grabbing that pack, the Rocks and Boulders 2. Yeah, so that does about wrap it up, I think. This has probably ended up being like the same amount of crazy long as the Amplify video, but I did try to speed this one up. Tried to get through things a little bit quicker, so I may have skipped over some bits. I would say for anyone who's a little bit confused with the nodes, like why I'm using certain things, I do explain quite a lot in the Amplify one, which is the video that I uploaded before this one. I'm not saying to go and waste your life and watch that just for an explanation, because I'm sure once you have the nodes, that's it. Who cares about like how it works? I don't know. It's kind of late here, so I'm just gonna go to bed now. Good night, and I'll see you in the next one.